All right, let's get right into it. Today, we're going to pull back the curtain on one of the most talked about technologies out there, generative AI. We're going to unpack the so-called magic and really see how these machines are learning to create art, text, and music that feels, well, incredibly human.
So here's the big question, right? We see the results all over the place. These amazing images, emails written by ChatGPT. But how does that actually happen? How does a machine go from simply recognizing what a cat is to dreaming up a brand new picture of a cat that has never existed before? That's the core mystery we're going to solve today.
Okay, so the very first thing you need to grasp is that not all AI is doing the same job. You can basically boil it down to two fundamental roles. There's one type of AI that acts like a classifier, sorting through the world as it is, and another that's a creator, making totally new versions of it.
And getting this difference is absolutely the key to unlocking everything else we're going to talk about. It's the fundamental difference between an AI that can label something and an AI that can imagine something. Think of one as the analyst and the other as the artist.
And here is where it becomes crystal clear. On one side, you've got discriminative AI, what we're calling the classifier. Its whole job is to answer a simple question: is this a cat or a dog? It looks at data and sticks a label on it. But on the other side, you have generative AI, the creator. It responds to a completely different command: create an image of a cat. It doesn't just identify, it invents.
Believe it or not, you use these discriminative models all the time. When your phone unlocks with your face, that's a discriminative AI making a call. Yep, that's the owner. When an email gets tossed into your spam folder, that's an AI classifying it as junk. It's just an expert at drawing lines and putting things in boxes.
And this is the creator. A generative model doesn't just learn the line between cat and not cat. No, it digs way deeper. It learns the very essence of catness by studying thousands of cat pictures, so it can then generate a totally new one from scratch. This is the engine behind ChatGPT writing a poem, or Midjourney creating a wild landscape.
So you might be wondering, if these concepts have been floating around for a while, why the massive explosion right now? Well, the answer really lies in this kind of big bang moment for AI that happened right around 2012. It was a perfect storm that just changed everything.
You see, for decades, AI progress would hit these walls. They called them AI winters. But then, after 2012, three crucial things came together at the same time. First, we finally had oceans of data, huge public data sets like ImageNet. Second, the hardware caught up. GPUs, the graphics cards built for gaming, turned out to be absolute powerhouses for training AI. And third, the algorithms themselves just got way, way smarter.
And once that fire was lit, it spread like crazy. In 2012, a GPU-powered model just shatters all the old records. Only 2 years later, in 2014, the wild idea of GANs is published, giving us a powerful new way for AI to create. And by 2017, the invention of the transformer architecture arrives, which is the engine that basically powers all the big language models we use today. It was an incredibly fast revolution.
Now, to really understand that huge 2014 breakthrough, we need to tell a little story. It's a story of two AIs locked in this high-stakes duel. Think of it as a master art forger versus a brilliant detective. This is the story of generative adversarial networks, or GANs.
The idea behind a GAN is it's pure genius. Instead of having one lonely AI trying to learn all by itself, you pit two AIs against each other. They're adversaries, and it's through their constant competition that they force each other to get exponentially better.
So let's meet our two characters. In one corner, you've got the generator. This is our art forger. Its one and only goal in life is to create fake images that are so convincing they can fool its rival. And in the other corner, you have the discriminator. This is our detective. It studies a massive library of real, authentic art, becoming an absolute expert at spotting fakes.
So, here's how this cat-and-mouse game plays out. First, the detective pores over real masterpieces to learn what's authentic. Then, the forger, starting from just random noise, makes a terrible first attempt. The detective, of course, isn't fooled for a second. It says, nope, that's a fake. But here's the brilliant part. That rejection is feedback. The forger learns from that failure, adjusts its strategy, and tries again. This back and forth happens millions of times, with the forger getting better at lying and the detective getting better at catching lies.
So what's the end game? This duel goes on until the forger gets so good, so unbelievably skilled, that the detective is basically just flipping a coin. It can't tell the real from the fake anymore. And at that exact point of equilibrium, the generator has essentially taught itself the art of creation. It is one.
But as amazing as GANs were for creating images, they had their limits. When it came to the complex, messy, nuanced world of human language, AI needed another big evolutionary leap. It needed something new. It needed the transformer.
I mean, think about it. Language isn't just a grid of pixels. It's a sequence, right? Where context is everything. The meaning of a single word can completely change based on all the other words around it. And to master that, AI needed a whole new playbook.
And that playbook arrived in 2017. It was called the transformer. And its superpower, its secret sauce, is this incredible mechanism called self-attention. Instead of reading a sentence one word at a time, a transformer can look at the whole paragraph, or even the whole document, all at once. It weighs the importance of every single word against every other word, giving it this deep, rich understanding of context. This is the tech that makes things like GPT-4 possible.
And that brings us full circle. We started out asking how a machine learns to create. We've seen how it evolved from a simple classifier into a sophisticated artist, using intense competition and a deep understanding of context. But now we're left with a much, much bigger question. When a machine can create things that are indistinguishable from what a human creates, what does that mean for the future of creativity itself? That's definitely something to think about. Thanks for joining me.